All right, today is a big day. This 1.5 lesson on shifting, stretching, and reflecting graphs is a big one. It's really important that you understand how this works because it's consistent through all of the functions that we'll talk about. So, looking at graphs today. Now, to start with, we have to have some basic graphs that we're familiar with, that we know what we call the parent graph, which means the most basic graph that there could be for that particular type of function. So let's start with a quadratic. We've done a lot with quadratics. The most basic equation of a quadratic would be a y equals x squared. Okay, that's the parent graph. If you look at a table, and this will be important that you remember what the table is for each one of these. If you plug a 1 in for x, you get 1 back. If you plug 2 in for x, now that we're plugging it into this equation right here, 2 squared would be 4. Plug in a 3. 3 squared is 9. And just to understand the basic shape of it, because what that's doing is that's creating ordered pairs and shows the steepness of the graph. And it's not linear, so it's not consistent. And so it gets steeper on the sides of it. It comes down here. Actually, 0, 0 would have been a point, and it goes up like this. And there's our parabola. All right, let's try it with a cubic. The most basic equation is a y equals x cubed. And if you think about what a table would look like on that, if you plugged in a 1, you'd get a 1. 2, you'd get a 3. But since it's a cube, let's throw in some negatives. What if it was a negative 1? Well, cubed would be negative 1. If you put in a negative 2, it would be a negative 2. I'm sorry, it'd be a negative. Okay, let me start over. If I plug in 2 and cube it, okay, I can't erase, sorry. 2 cubed is 8. And then negative 2 cubed is a negative 8. All right, let's sketch that. All right, so over 1, up 1. Over 2, up 8. Big difference there. It goes up a bunch. Okay, again, I'm kind of dodging the 0, 0 point every time, but it will be there. And then negative 1, negative 1. And negative 2, negative 8. And it creates this little wave in here. So that is our parent function and what a cubic will typically look like. And we need to remember the table for it. Let's try 2 more. Another type of function that we've worked with is an absolute value. So an absolute value would be something like y equals absolute value of x. That's the parent function. I'm not multiplying or adding anything. It's just the variables. If you do that, you plug in a 1. You get a positive 1 back. 2, you'd get a positive 2. 3, positive 3. You could throw in a negative. All it's going to do is go back positive. Okay, so let's look at the graph then. This is the one. 0, 0 would work. 1, 1, 2, 2, 3, 3. Could go with the negatives and get the same thing to happen. This is a nice V-shaped graph. It has a slope of 1. Last one, a square root function. It looks like this. And if I were to plug in values for x, now since I'm going to take the square root of x, I'm going to kind of hand pick some numbers here that work nicely. So I'd put in a 1 because the square root of 1 is just 1. But I'm not going to put in a 2 or a 3. I'd choose a 4 because I can square root 4 nicely and end up with a 2. And the next one I would probably jump to is a 9 because I can square root that and get a 3. So if you think about what a graph looks like, it'd be 1, 1, 4, 2, 9, 3, and 0, 0 would work. And what it is actually a sideways parabola. If you look at this table compared to our parabola table, it's just flip-flop. Sometimes I just graph the square root function by turning my head sideways and graphing a parabola instead. Now notice it's only going to be the top half, the positive part of that. Now, it's very important you know those 4 things, and if you haven't taken notes on those, you need to because you're going to look back at these for each of the future graphs. So pause if you didn't write that down and we're just watching, you need to jot it down. Pause the video. All right, here's the big thing. When you write your equation and you start messing with it a little bit, and it's not going to be the parent function anymore, but you might be adding or subtracting something. You might be multiplying by something. Now, this particular one happens to be a quadratic, but it works the same way if these were absolute value or if it was a square root. They all do the same thing. This will be a very common situation. So let's talk about what each one of these variables will do. Okay, when I look at this, I see y equals, and then I'm going to take a times whatever I had there. So that a is going to take all of my y values and multiply them by something. Okay, in general, what it's going to do is it's going to stretch or it's going to shrink my graph vertically because it's affecting my y. My y is going to be much, much smaller. If a is a small number, then that would be a shrink. But if a was, and when I say a small number, the parent graph is assumed to be a 1. So if it's smaller than 1. If it's larger than 1, then it's going to make all my y values bigger, and it's going to stretch my graph really long ways, tall, skinny. Okay, so let's look at what h does to my graph. H is tucked in here with the x, so it affects my graph horizontally. And it basically is just shifting everything, and it always shifts the opposite direction of what you'd see here. Anytime you're inside of grouping symbols, your motion is the opposite of what you might think. So if I have a minus h, it's going to move it horizontally, so in this case it'd be a plus whatever this is. So minus 3, then I'd move everything right 3. All right, so we call that a shift. And it's going to shift it horizontally, left and right. And I'm always going to do the opposite because it's inside the parentheses. All right, the last value that we're going to throw in these equations is this number out at the end that's going to get added. And since it's out of the end and not part of the parentheses, then it affects the y value. So it would take all these values right here that this would have given me, and it's going to make my y equal that much more. So it's going to move it up or maybe down if it's a minus sign. So it's a shift vertically. So it could go up or down. You do what the sign says. So same as sign is what I'll write. Maybe up here I should write opposite as the sign, whatever the sign says. This works for every single function we're going to come across. So specifically the ones that we just did, the absolute value and the cubic and the square root, we're going to work on those today. Okay, so here it is. This is going to be a quadratic. And so after we do this today, I'm pretty much expecting to be able to graph something like this without a graphing calculator. First thing we need to recognize is it's a quadratic, which means it's going to be that parabola shape. Let's go through what each one of these numbers does. Okay, this is going to stretch my graph vertically. Remember I said it's going to take all of the y values and it's going to end up making them all times 2. So I'll end up coming back and multiplying those all times 2. So that kind of tells me the shape of my graph. These two values affect my vertex. It shifts me left and right, up and down. Now the vertex on the parent graph is at the origin. So we're always going to be taking that origin point, that vertex point, and moving it around. So the first thing I'm going to do is I'm going to take my vertex and I'm going to move it right 4. Remember, because you do the opposite inside parentheses, and because it's with the x, it's my left and right motion. Okay, this one's going to affect my y's. It's going to move it up and down. I do what the sign says, so I'm going to move it down 5. So that's the first thing I'm going to do is get that vertex put in the right place. So now instead of being at the origin, it's going to be right here. And then I use my table. I normally would have gone over 1, up 1. From the vertex now, I'm going over 1, up 1, 2, 4, 3, 9. But now everything is times 2. So it's really over 1 up 2, over 2 up 8, over 3 up 18. I'm taking all of those y values times 2. So from the vertex, I go over 1, up 2, and I get a point there. And you can go ahead and put its matching point. Everything's symmetrical, so we'll put a matching point on the other side. All right, the next point would be over 2, up 1, 2, up 4, but it got multiplied by 2, so it's up 1, 2, 3, 4, 5, 6, 7, 8 right here. And then put your matching point on the other side. Okay, normally from the vertex I'd go over 3 and up 9. Now I got to go over 3 and up 18. That's going to be way off my graph, so I'm going to call this good. I usually like to get at least 5 points plotted for my parabolas to kind of get a nice shape. Okay, so that would be typically a little bit skinnier of a graph because this is a 2, so it's stretched it. I think of it kind of like a rubber band. If you stretch it vertically, it's going to force it to be a skinnier looking parabola shape. All right, so there you have it. Let's try another one. All right, this one is an absolute value. So we have to know the parent table for the absolute value, so I've written that down from previously. And you just have to know these tables or be able to create them real quick, knowing that what the parent graph is, knowing this, and be able to create that real quick. All right, ideally you don't have to create it, you start to remember some of these common ones. All right, the -1/2 is going to take all of my y values times a -1/2. Now that's interesting. Think about what a negative is going to do. Well, that's going to change this to a -1/2. 2 is going to turn into a going down 1, and 3 is a -1.5. All right, so let's try this. First thing I got to do is get my shifting. So it looks like this is my horizontal movement. I'm going to go right 2. And I am going to go up 1. And plot my new vertex. So right 2, up 1. Here's where the vertex is going to be now. All right. Normally on the parent graph, I would go over 1, up 1. But this time I have to go over 1, and since it's negative, it's going to go down 1/2. Okay, and I'm going to put its matching point in. Remember, we're looking for this to be a V-shaped graph. Okay, from the vertex, I'm going to go over 2. Normally it'd be up 2, but now I'm going to go down 1. Put in a matching point. Last time 3, down 1.5. Matching point. I've got enough there to get the gist of what's going on. There's my graph. Notice that my V shape went upside down. Okay, that's something you need to go back in your notes and jot down. Anytime you have a negative A value, so back there on that screen where we wrote the A value, if it is negative, it's going to flip your graph upside down. It's going to reflect it, and what it reflects over is the x-axis. So it's always going to look like it's upside down if you have a negative A value. So you need to write that back there where we had written about the A, H, and K. Okay, let's try a square root graph. Okay, remember this looks like the sideways parabola, but it's only the top half. Let's start with our shifting. And so it looks like we will be going left 1, because that's in, see, this is like your grouping symbol, your parentheses, your absolute value. This is tucked in here with the X, so it's affecting it horizontally. So I'm going to be going left 1. Okay, notice that I don't have anything out here. So that means I'm not going up or down at all. I'll write up 0, but if there's not a value out there, it doesn't move it. Okay, so that means that my new vertex is just left 1. So this is my new vertex. Okay, so the y values all get multiplied by 3. So I'm going to come over here and take all of those times 3, all of that times 3. So now that's a 3 and a 6 and a 9. Okay, so when I would normally go over 1, up 1, I'm now going to go over 1 and up 3. So over 1, up 3. It's going to cross right there now. Okay, and then I'm going to go to the next point, and then I'm going to go over 4. 1, 2, 3, 4. Normally I'd go up 2. Now I'm going to go up 1, 2, 3, 4, 5, 6. Okay, over 9, which takes me to here. Normally up 3. Now I'm going to go up 9, which would end up right here. Okay, so there is my top half of my sideways parabola there. Got stretched vertically because of this 3, making it a much taller looking type of graph. Okay, how do you feel like you're doing? Are you getting the gist of this? Let's try one more. This one's a parabola. I'd like you to try this one on your own. See if you can get your vertex placed and then deal with your table so that you can get your points plotted. All right, pause the video. Go do it on your own. Okay, ideally you could figure this all out. This is the shifting that goes on for your vertex. So this is your new vertex point. You had to take all of your y values times 2, so these are the new values. And so now I'm going to go over 1, up 2. Over 2, up 8. Over 3, up 18. And I'm going to plot those points. So 1, 2 gets me to there, matching point. Over 2, up 8 gets me to here, matching point. And probably over 3 up 18 is going to be off of my graph, and I'm content with my 5 points, so I'm going to call that good. Remember that it's a parabola, it's curvy at the bottom, as skinny as it might get, don't make it pointy. Okay, and that's our parabola. How'd you do? Okay, we're going to try going the other way now. What if you already have the graph there? Could you come up with the equation? All right, so we're going to try a few of these. First thing you got to do is know what you're looking at. This is a square root graph. So you got to know that you're thinking of your parent graph that looks like this. And then you have to start messing with the shifting and any kind of stretching that's going on. So first of all, let's go to this vertex point and see what happened. It looks like we went left 2 and up 3. So do you know where to put those values? Well, the shifting happens inside the parentheses. That's your left and right shifting. Since I went left, I'm going to put the opposite sign. So it'd be an x plus 2. And then outside of the square root should be my vertical shift, so up 3. And then the other thing we have to find is this a value. Now, when you look at this, you kind of have to go back and know what your table says to do. It says to go over 1, up 1, and we hit the graph right there. You can go over 1, 2, 3, 4, up 2. We hit the graph. Okay, so it looks like we didn't have any stretching. This does exactly what the parent table does. So that means that my a value is just assumed to be a 1, just like it is in the parent graph, and we don't put anything there. Let's try a parabola. Okay, so when we look at this one, we start off with our shifting, and look, we don't have any. It's still at the origin, so I don't have to worry about any shifting whatsoever on this. I don't have an H, I don't have a K. But this one is not your normal shaped parabola, so I think we're going to have an A value out in front to deal with. First of all, it's upside down, so I know it's going to be negative. Then I have to work on this right here. Okay, there's 2 ways to do this. If you're pretty good with number sense, I want to show you how you can just figure that out just by looking at it. Okay, so think of your parent graph. It's a parabola, so it looks like this. We've decided we're not going to have any addition subtraction at all. It's just an a value that we're searching for. Now, if you remember your parent graph on a parabola, that's 1, 1, 2, 4, 3, 9, because you're squaring everything. So we didn't do that. We went... Well, what I'm going to do is I'm going to look at this point that we have here. Instead of going 2, 4, we went 2, 2. So think of what portion of the way that you went. If you only went 2 and you were supposed to go 4, what did we just multiply that 4 by to get that? Well, we went half as far as we were supposed to. So that tells us that our a value is actually going to be a 1/2. And the fact that it's upside down tells it's going to be a negative 1/2. So there's our equation. Okay, so if you're good with number sense, you might be able to just look at this and figure out the a value. It's not always going to be quite that pretty though. So let's look at another way to do it, an algebraic way that would work. Now this one is kind of a basic one because I don't have that h or k to deal with, but I would normally go ahead and plug in the h and the k. I don't have it. So what I do then is once I put in an a because that's what I'm searching for here. This is pretending we didn't already figure this out. And then it's an x, and I don't have an h or a k to deal with, so I could just put an x squared. And then what we do is we take that point that is determining the width and the stretch. We take that point and plug it in for x and y. So the y is -2. We don't know a, and then it's going to be a 2 squared. So what you do is you go solve for a. Divide by 4. Oh, there it is. Look, -2/4 is -1/2. So that would have been another way to go figure out that a value, and then we would have plugged it in and written our equation just like we did there. Now I'm probably going to do this algebraically so that you have a pattern, a method to do that, and then I'll come back and see if we could have done it without having to do it algebraically. Okay, so here we are. This one is an absolute value. It's a V shape. So here's my parent graph. Now we got to put all the shifting business in there, and that's this vertex right here that told us we went right 5 and down 2. So now let's change it. We don't know the a yet. Absolute value of x, we went right 5, so that's a -5. And then we went down 2. Now I'm going to take this ordered pair, this 6, -6, and I'll plug it in for x and for y and go find the a that would make this work. So y is -6, don't know a, absolute value of x, I'm sorry, not x. We're going to plug in for x a 6. -5, absolute value -2. And now we're going to solve for a. So our first step is to add the 2 to the other side. So then you get -4 equals a, and I'm going to go ahead and do this. I have a 6 minus 5, that's 1. Absolute value, still 1, so it's basically just times 1. Okay, so a is equal to -4. Once you know your a value, then let's rewrite our equation and put it in there. So final answer, y equals -4, absolute value, x minus 5 minus 2. Okay, let's check real quick. Could you have figured out that -4? What do you think? How about the negative? Does that make sense that it was negative since it's upside down? Okay, you have to know your parent table. On the absolute value, it was just 1, 1, 2, 2, 3, 3. So if I were to look at this extra point they gave me, it's supposed to be over 1 down 1 if it was negative. But I went over 1 down 1, 2, 3, 4. I went 4 times farther than what I was supposed to, thus it's a times 4. Okay, let's try it one more. Last one. Why don't you give this one a shot without me? See, it's a nice parabola shape. They give you the vertex, and then they give you that XY that you can plug in. Pause the video, try this one on your own. All right, based on the shifting, you should have gotten a +4 and then a +2. I'm going to walk you through the A part. Okay, the y value of this extra point that the parabola is supposed to land on up here would be 14 equals a, plug 0 in for x from the point, square it, +2. We end up with a times 4 squared is 16. Add the 2. Make sure you don't add the 16 and 2. Order of operations ties these together, so you really should be subtracting 2 on both sides. So that's 12 equals a times 16, divide by 16. Okay, I can see this wasn't going to come out near as nicely. A ends up reducing. We want to reduce it to a 3/4. Okay, final answer then, y equals, a value is now 3/4, back to the top equation where we got our shifting figured out. Here's the equation of that parabola. Okay, that 3/4 would be a little trickier to come up with. If you look at the graph, it looks like I went over 1, 2, 3, 4. Okay, on the parabola, my table, since I'm squaring everything, would be 4/16. Let's look at what we did. We didn't go up 16, we went up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, sorry, I lost track there of where I was because it's way off the graph, and that's not necessarily to scale. So let's just use some common sense here. If I was up 2 and I ended up 14, then I went 12 units that way. Okay, so I went 12 of the 16 that I should have gone. Do you see where the 12/16 comes from? And that would reduce to a 3/4. So you can do it even if it doesn't come out nice. It's just not quite as easy just to do in your head. Okay, this is important stuff. Really need you to learn it. Good luck.